Hi there everyone. If you're seeing this, then I assume you are on part 2 of the second CrystalMaker assignment. And in this part of the assignment, we're going to be filling out a data table. This data table involves all the minerals that you have chosen to represent each of the crystal systems. We're going to take a look at their unit cells and the edge lengths of their unit cells, and then look at the angle between those edges. So I'll explain what that means a little bit more, and I think it's easier to see if I bring up a mineral. So this is a mineral called ulexite, and this is just one that I've chosen to demonstrate on. Now this is a triclinic mineral, and so that means something very particular. And if if you're not familiar with what that means, we go to our textbook, and we can see that based on the crystal systems table, triclinic minerals, none of their edge lengths should be the same. So on our data table, we have these edge lengths. So that means that if I'm in the triclinic crystal system, none of these three numbers should equal each other. And the same can be said for the angles between those axes. None of these angles will equal each other. Okay, but what does that really mean? So I mentioned before, my mineral is ulexite. So that's my mineral to represent the triclinic crystal system. And now I want to go back to CrystalMaker. And I mean, this is a bit of a mess, so I need to get this down to one unit cell so that we can measure the lengths of the unit cell. So if you don't remember how to do that, we go to set range and then one cell. So that was transform, set range, and then click one cell, and we're good to go. And just a quick note, if you don't like how your unit cell looks, like mine, the default is just it's represented with this kind of orange, I'd kind of like to change it. So I think green stands out nicely, so I'm going to make my unit cell green, because why not? You can also change the style. You can make them solid lines. You can make them, ooh, that's not nearly enough. Let's go. Whoa, too much. Too much. We'll go back to 1. That's fine. So anyway, just pointing out that if you want to, you can change the unit cell characteristics. But more importantly, we can also change the vector labels. The bottom left here, these vectors, that lets you know what axis you're looking down and what the deal is. You want to go in here, or at least I want to go in here and change the labels to A, B, and C, because that's what's listed on our data table, A, B, C. Okay, so now we have a unit cell, now we have the vectors labeled correctly, now my color is nice and green. So what is the first thing to do on our data table? Well, after we put in the mineral name, we want to measure the length of the A edge. And so to be as precise as possible, we're going to use the viewing window, or the viewing menu. Sorry, I keep opening stuff. View, and A, right? I want to look down the A to measure the A. Not quite, because you can see the vectors. A is going directly into the screen. I can't measure its length right now. I can't see it. It's going directly away from me, so I need to look down a different axis. How about B? Okay, now I can see A. It's indicated by this red vector. It's this edge. I want to measure this edge. And so to measure distances, we're going to come over to our toolbar, and we're going to click the double arrow, this tool right here. And now I'm going to zoom in slightly just to make it easier on myself. I'm going to click just about as precisely as I can the corner of the unit cell. And then I draw down the A. I know this is the A because I can see the vectors in the bottom left of my screen. I know this is the A length. And then I'm going to click again. And so now I can see this number here represents the distance in angstroms. So this is 8.526. So I go back to my document, 8.526 angstroms. And that's good. Now we know that. So now we need to measure the B axis. But right now I'm looking down the B axis. I can't see the B axis. So if I go back to looking down the A axis, now I can see the B. It's running side to side here. So I go back to my distance measuring tool, and I click the corner, draw my distance, and then click again. And I can see it as a distance of 12.433 angstroms. 12.433, is that right? It is. 12.433 angstroms. And now, next step, I want to measure the length of the C edge. And, oh, look at that. Based on the vectors here, I can see that the C is running up and down, so I don't have to change my view anymore. I just go back to my distance tool, I click the corner here, I go up, 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 until I'm just at that corner, click. And if I turn my head sideways, I can see that says I have measured a distance of 6.3 angstroms. 6.300 angstroms. Okay, now let's pause for a second and check our thinking. Our book said something about the relative lengths of the axes in the triclinic crystal system, which I know we're in. And it says that A should not equal B and B should not equal C. None of the lengths of the axes should equal each other. And if I look at my data table, well, that's the case. 8.5 does not equal 12.4, does not equal 6.3. None of them are equal. So we're good. Next thing to do, though, is we're going to have to measure the angles between the edges. And for that, basically just want to keep a close eye on the vectors. Again, it's just going to be more important right now. If you have forgotten, this is in your textbook. I grabbed a screenshot of it. We're going to be measuring the alpha, beta, and gamma angles. Alpha is the angle between C and B. Beta is the angle between A and C. And gamma is the angle between A and B. Okay, so let's take a look at CrystalMaker and see what that means. So right now, we are looking down the A axis, and so that means that I can see the angle between B and C. B is running sideways, C is running up and down. So this angle here is the angle between B and C, but I kind of forget, what was that again? Angle between B and C, angle between B and C. This one here, the alpha angle. That's what I can see at this corner. So to measure angles in CrystalMaker, we'll use the tool right below the distance measuring tool, this guy, angle measuring. And same deal, I'm just zooming in so I can get a better look at that corner. And so we want to click right on the line if possible. And then you draw a distance. You get to the vertex. Get right on there, click again. And now, hopefully you can see on your screen. Maybe you can't because my camera's in the way. Try to zoom out. There. So we go back to the angle measuring tool, and click, get to the vertex, we click again, and now you should be able to see an angle being measured. So we want to line that up, right up and down, just right there. Okay, so the angle, based on the vectors, between B and C, which, based on the textbook, I know is the alpha angle. The alpha angle is equal to 96.14 degrees. So we go back to the data table, alpha, what was it again? 96.14? 96.14. Good. Now we want to measure the beta angle. The beta angle is the angle between A and C. So we got to go back to CrystalMaker. We'll zoom out, zoom out, zoom out, zoom out. And again, beta, angle between A and C. So I can't see the angle between A and C right now because I'm looking down the A axis. What if I look down the B axis? Oh good, now I can see it. C is going up and down, A is running side to side. So this angle here, this corner, is going to be the beta angle between A and C. So I still have my angle measuring tool selected. I click, go to the vertex, get just about as close as I can. Click again, angle being measured, click again, and so the angle between A and C is 109.86 degrees. So we'll go back to the data table. What was my angle again? 109.86 degrees. Lastly, the gamma angle, the angle between A and B. And so if I go back to CrystalMaker, well, I can't see the angle between A and B. Zoom out again. Can't see the angle between A and B because I'm looking down the B axis. So I got to look down a different axis. Oh, perfect. Now I can see down it. You can see based on these vertexes here, A is running side to side, B is running up and down. So with the angle measuring tool selected, I go to the edge, click, go to the vertex, click, measure my angle, click again, 106.02 degrees between A and B. And I know that's the gamma angle. It was 102 point, what was it again? 106.02 degrees. And again, let's check our logic. In the triclinic crystal system, A does not equal B does not equal C. We already checked that, we're good. And alpha should not equal beta, should not equal gamma. Alpha, 96, should not equal beta, 109 should not equal gamma, 106. None of them are equal. So we've now proven to ourselves that ulexite is a mineral in the triclinic crystal system. So hopefully with this demonstration that makes your job a little bit easier. You'll do this for each mineral that you chose to represent the crystal system, and have fun.